All right, Unit 4. We're on to the second half of the course. So, this lesson or this unit is on acids and bases. And this first lesson is just going to be an introduction to acids and bases, starting with 4.1, which is going to be the Arrhenius theory and neutralization reactions. So, just a little recall from Unit 3 is that all acids and bases are ionic compounds, meaning that when they are dissolved in water, they form ionic solutions, meaning they are ions free floating in solution. Because of that, their solutions conduct electricity and we can call them electrolytes. So, for example, when we write an equation like hydrogen chloride gas dissociates into its ions, meaning the hydrogen and the chloride ions, these are aqueous because they've been dissolved in water. So there's a part of this reaction that we're going to write soon enough, but we have to get there, where this would actually be hydrogen chloride gas plus water, and then it's forming its ions in solution. But as a simplified form right now, we're going to say something like a hydrogen chloride gas can dissolve in water and form aqueous ions, hydrogen and chloride. So the Arrhenius theory of acids and bases is simply that an acid is any compound that produces hydrogen ions when dissolved in water, and a base is any compound that produces hydroxide ions when dissolved in water. So a really nice simple example would be the hydrochloric acid above or nitric acid. So if you have nitric gas, or what would that be then? Hydrogen nitrate gas is going to be dissolved in water. It will form hydrogen and nitrate ions. If you have sodium hydroxide solid getting dissolved in water, it's going to form sodium and hydroxide ions. And the most important thing is the nitric acid produced hydrogen and the sodium hydroxide produced hydroxide. So, to make it even simpler, acids start with H, bases end in OH, and salts are all the other ionic compounds, so metal, nonmetals, or organic acids that will dissociate and form electrolyte solutions. So things like a potassium chloride, right, doesn't start with H, doesn't end in OH, but it is a metal and a nonmetal, and so on. So I did mention organic acids, but I mentioned them under salts because even though they end in COOH, they do not release an OH, right? They just release a hydrogen or dissociate into a hydrogen ion. So I've got 4 examples down here. All I want you to do is pause the video and give a think. Which of these are acids, which are bases, and which are salts? And if they are none of them, maybe an organic compound, you would say none. Okay, pause the video, give it a go. So let's start with the easy ones, right? Let's start with the acids. The acids are the ones that start with hydrogen. So this guy is an acid. Then let's go on to the bases. The only compound that is going to end in a hydroxide is the barium hydroxide, so this is my base. Then let's move on to my salt. So my salt is any metal, nonmetal, or metal and polyatomic ion, or my organic acid. And so that is going to be my sodium nitrate. So this guy is going to be my salt. And then this is an organic compound, right? It's made up of carbons and hydrogens. It's not starting with a hydrogen, and we will call this one our none because we would call this molecular or organic. Okay, so that's the first thing, Arrhenius theory of acids and bases. The second thing we're going to look at is what is a neutralization reaction. When acids and bases are mixed, a neutralization reaction occurs, meaning that there is a double displacement where water is always one of the products and then the leftover will be a salt. So if I was going to write the neutralization reaction between this, I'm having one of those, like, what do I call those moments? H3PO4 is phosphoric acid and calcium hydroxide, I know that it's going to form water. Now, the way that I wrote that above, I should put H2O on the end here. Okay, it's going to form water, and then the other thing is going to be a salt. So if we think of this as being a double displacement, we're going to get the water from the hydroxide and the hydrogen. So then the salt that's going to be left is going to be the calcium phosphate. So calcium is a 2 plus charge, phosphate is a 3 minus charge, so it's going to be calcium, phosphate. My fours never look like fours. Eventually I will just give up. Phosphate, there we go. And then there's going to be two of them. Then all we have to do is make sure that we balance this reaction. Now the balancing can be a little bit tricky. I always start with my like the calcium. So over here on the left-hand side, I only have one calcium and I have three over here. So I'm going to put a 3 here. And then I've got two phosphates, so I'm going to put my 2 here, and then I'm going to just balance the hydrogens and the oxygens with the water. So you'll see I have 6 hydrogens on the left plus, so I have 6 hydrogens from this compound, and then I have another 2 times 3, I have another 6 hydrogens from the calcium hydroxide. So that's going to be 12 hydrogens, which means my plus sign is too close to my water. It means I'm going to need 12 hydrogens. So I'm going to have 6 of these, and then let's double check the oxygens. So on the left-hand side, I have, how many oxygens? 8. Oh, wait, don't count those phosphates. Haha, I almost counted those oxygens. I don't. I just need to count these ones. So there's 2 oxygens in my calcium hydroxide, and then there's 3 sets of those, so there's 6 oxygens. So there are 6 oxygens on the left, 6 oxygens on the right, not counting the ones that are tied up in that polyatomic phosphate, and I am balanced. So why don't you give the next one a go? Pause the video. So for me, I'm going to have this calcium chloride salt, and then I know I'm going to produce water, and then I'm just going to make sure that this is balanced. So I have 2 chlorides on the right. I need to put a 2 here. That gives me 4 hydrogens. So if I put a 2 here, and then I've got 2 oxygens, that was much more straightforward. Awesome. That's 4.1.